and distinguished guests. I, Gaurav Bhatnagar, on behalf of NCCBM, welcome you all to the 9th technical session on energy conservation systems. We are extremely honored to have Shri Rajesh Kakkar, President, Technical Birla Corporation Limited, amongst us. I would like to invite you, sir, to kindly come on the dais and chair this session. Thank you, sir. I would now like to call upon Mr. Detlef Blümke, Managing Director, Loesche, to kindly join respected chairman and co-chair this session. Thank you, sir. Now, I would like to invite Shri Ankur Mittal as NCCBM representative to kindly join the dignitaries on the dais and take this session forward. Thank you, sir. Over to you.
Good morning. A happy and energetic morning to all. So today we are assembled here for session 9A, that is energy conservation systems. The less you burn, the more you earn. With this message, we are going to witness 8 number of excellent presentations that will tell the best practices that they have adopted in their areas. So today, it's an honor to share the space and dais with the eminent personalities of cement industry. I welcome Shri Rajesh Kakkar, President Technical, Birla Corp Limited, as chairman for this session. I also welcome Mr. Detlef Blümke, MD Loesche, as a co-chairman for this session. So now I request Chairman Sir to start the session.
Good morning. Today's technical session 9A is on energy conservation systems. And as Mr. Mittal told, a unit saved is a unit generated, earned. So this is, energy conservation systems are the frontline fighters for the net carbon, zero carbon emissions. So today we have 8 papers, and I am sure these whole 8 papers will enlighten you about energy conservation measures which we can take for saving of energy, and to meet, it will facilitate to meet our net carbon zero emission levels. Now, I request the first paper, there will be 8 papers, and 1.5 hours total time is there. I'll request each presenter to limit his presentation on 8 minutes, within 8 minutes, so that we can have some discussions afterward. So to begin with, we start with the paper of electrical power optimization for free of cost export, presented by U.S. Chaudhary, R. Durgaram, and Kerajram Chaudhary of JK Cement Works, Muddapur. Please.
Very good morning, jury members and audience present over here. Myself, Jyotiba Shinde, Electrical Manager and also Certified Energy Manager from JK Cement Works, Muddapur. First and foremost, thank you NCB for giving me an opportunity to showcase the case study of electrical power optimization for free cost export power. JK Cement is a flagship company of JK organization which established in 1975, and group having a captive power generation of 145 megawatt, which includes 42 megawatt of waste WHRS power plants, and about Muddapur having a CPP of 50 megawatt and 18 megawatt WHRS project is in progress. JK Cement Muddapur is a several ISO certified company. Several ISO certified company. We proud and privileged that JK Cement Muddapur is a standalone integrated cement plant in India, awarded a prestigious Greenco Platinum rated by CII, and also Great Place to Work certified company. JK Cement Muddapur having a captive power plant of installed capacity of 50 megawatt, which having a 2 units of 25 megawatt each. We operate CPP in 2 mode, island mode, that is off the grid, and synchronous mode with the grid. We prefer synchronous mode to sell the surplus power and to accommodate the incremental sharp load during ST drive starts. The issues has been identified that the pre-op cost export power was injected to the grid in under unscheduled manner during cement plant load variations. The table over here for pre-cost export power on month-wide data has been clearly indicates that around 150 megawatt hour of per month pre-cost export was injected to the grid. In order to optimize this pre-cost export power, we conducted a driving course, and our aim is to making this pre-cost export power to 0. However, we required to operate the CPP under synchronous mode under certain conditions. With the effective power optimization drive, we came up with a 2-phase controls to control the pre-cost export power. That phase 1 optimization proposed the island mode and implemented and disconnected most of the time from grid. And with phase 2 optimization, we in-house designed the export control logic for effective control of synchronous pre-cost export power. The phase 1 optimization, that is island mode operation, we adopted the island mode operation most of the time. However, CPP has to be synchronous mode under certain conditions like ST drive start time to accommodate the incremental kick loads, and during coal feeding issues like high moisture, wet, and load fluctuation due to unplanned plant shutdown, stop. Further improvement in phase 1 optimization has been carried out with the brainstorming session that all the cement mills emergency stop, additional stop push buttons has been provided at CPP CCR, and their respective run feedback also taken in CPP CCR. Results of phase 1 optimization, with adaptation of island mode most of the time, the tabulated pre-cost export power on month-wide data has clearly shows that around 50% of power reduction has been taken from phase 1 optimization. Some of the constraints in phase 1 optimizations are unplanned cement mill stops or trips, the boiler and the steam venting. This causes our heat losses. And to accumulate the incremental kick load, we have to go for a synchronous mode. And often sink and island operation of sink breakers. The sink breaker falls in premature maintenance. With phase 1 optimization, we however achieved the good result at certain level, but our aim was 0 free cost export was not achieved from this phase 1 optimization. In order to achieve this 0 free cost export power, we moved into phase 2 optimization, where with few consultant and feasibility studies, with a cross-sectional brainstorming session, we in-house designed the export control logic and adopted in our DCS. This export control logic works whenever the export power exceeds the set point, that is 0 megawatt. This export logic automatically decreases the STG load by control mechanism. And whenever STG load is below 7 megawatt, this export control logic withdraw automatically for safer operation of boiler. With the phase 2 optimization, the results shows that the power losses has been drastically reduced, and finally we achieved the 0 free cost export for the last of the 2 months, February and March 2020. From this slide, the pre-cost export power from preliminary to phase 1 implementation and then phase 2 implementation shows gradually decreasing trend. Achievements with these both of the optimization, with the preliminary 150 megawatt hour per month, we able to reduce it to 80 megawatt hour per month, and then with phase 2, 3, and even lastly we achieved our goal 0 at the last 2 months also. With saving from phase 1 and phase 2 optimization, with phase 1 optimization, we saved around 70 megawatt hour per month at a power cost of 7 rupees. We saved around 59 lakh per annually. And with phase 2 optimization, 75 megawatt hour per month at a power cost of 7 rupees, we able to save 63 lakh per annum. And with both optimization, around 1.22 crore per annum saving has been occurred. Replica potential. We, JK Cement Muddapur, have studied the power optimization and energy conservation technique and implemented in and achieved. Same has been followed and implemented by JK Cement Works, Nimbahera, Rajasthan. Conclusion of this energy conservation, with phase 1 optimization, adaptation of the island mode most of the time, and with the phase 2 optimization, in-house design of export control logic in our DCS, we finally achieved zero free cost export from preliminary losses of 150 megawatt hour per month. As of now, CPP is now in stopped condition due to coal crisis and high generation cost. This concept can be horizontally adapted to any of the CPP where the CPP is running in sync mode. Thank you once again, jury members. Thank you.
Thank you, sir. Thanks for your interesting presentation. Actually, you should run, whenever it runs, always in the synchronization mode. In this way, you will save coal in the power plant. And strictly speaking, you cannot feed back power to the grid unless somebody has authorized you to do that. Thank you for your good presentation. Now, the second presentation is process stabilization and energy conservation at PHFAN SPRS. Breaking the Loss Iceberg by Technological Exploration by Mr. K.P. Srivastava and N.S. Rao of My Home Industries Private Limited.
Good morning, all designatories. Welcome to technical session 9th on energy conservation system. I am K.P. Srivastava from My Home Industries Private Limited MCW plant and going to present on process stabilization and energy conservation at preheater fan SPRS. Before moving ahead, I express my gratitude and big thanks to NCCBM and My Home Management, who has provided such grand platform to showcase our excellence in the global horizon for benefit of various industries associated and world as a whole. This endeavor is aligned with the noble objective of moving ahead net zero carbon emission. This is the overview of MHIPL. It is in Melacheruvu village and at Suryapet district, Telangana state. And it has 2 integrated cement plant at Suryapet district and other at Kurnool district. 10 megawatt capacity, 5,000 plus dealer sales network, 23 regional officers, 95 megawatt captive power plant with WHR, and 15 megawatt solar power plant. Then this is another overview for MCW, focusing on MCW. So there are 3 kilns, kiln 1, 2000 TPD, kiln 2, 3200 TPD, and kiln 3, 3600 TPD. We have own rack loading and unloading siding. CPP 1 and 2 combined 75 megawatt captive power plant. CPP 3 is 12.5 megawatt WHRS and alternate fuel plant of 8 meter cube per hour. Energy conservation technology by technological exploration we are going to discuss and elaborate. This is very significant in the entire process of evaluation, growth and survival of the world. The increasing energy demand has adverse effect on environment also. The demand in our country is rising exponentially. Its convention can be the best solution for bridging demand and supply gap in the energy supply chain. Cement manufacturing needs high energy consumption, and as we know, electrical energy is one of the major component of the energy total requirement in the cement plant. So this has reduced losses. We have achieved conservation by reducing the losses and resulted a tangible benefit of 65.7 lakhs per annum at the tune of 65.7 lakhs per annum. The process stabilization has also improved and smoother control of preheater fan speed, which has major intangible benefit. The technological exploration is successfully achieved a year back, and after sensing the need to break the loss iceberg. The wider range of speed control through SPRS in operation is working consistently after modification. Its advantages are delivered and delighted by the end customer, plant maintenance, and plant operation team. This is another where we have stated the problem statement. Basically, there was constraint of running kiln 1 preheater fan in SPRS mode during normal operation, and startup whenever kiln feed was reduced or need to reduction of preheater fan RPM below 74% of rated. So the changeover RPM cutoff was high and reduction was troublesome. So either it was switching to GRR or it was tripping with high current hunting. So thus lower cutoff RPM of SPRS was explored, and we have reduced this speed 74% to 68%, 67%, and thus we have achieved wider range of speed control. Then there are other methods of controlling a HT drive like LRS, GRR. This is GRR principle, then slip power recovery principle. This is normal slip power recovery system where inverter and rectifier and inverter are used to convert the slip power and fed back through transformer to the grid. That way it is saving the power. SPRS principle is explained, SPRS circuit diagram is explained. Diode bridge and rectifier bridge, these are the major components of any SPRS system. Then scenario of technology. Basically for speed reducing, we have other options also available. As the SPRS is old technology and it has limited range of speed of control, the other method like MV drive is also widely used in latest modern plants. But in our MCW also, there are in line 2 and 3, we have MV drive. Okay. However, in line 1, there is SPRS, and MV drives are expensive, and upgradation from SPRS to MV drive needs capex of rupees 1.5 crore and plant stoppage of 1 week, minimum 1 week. Possibility was explored to increase RPM range of control of SPRS so that wider range of speed control can be achieved with existing setup. So that was the endeavor. These are the drive specification. It was 1500 kilowatt, 6600 volt, 990 RPM, LNT make, Allentor model, and year of installation of SPRS is 2000. Methodology adopted was brainstorming was conducted among the concerned participant of electrical, process, mechanical, and instrument streams for solution of quick changeover of SPRS from GRR after startup of the plant. Full preheater fan damper operation condition was explored. So study was done and control method was adopted. Longer time was taking while starting the plant to switch SPRS mode to GRR. Preheater fan used to run in GRR mode hours and hours, causing higher electrical energy consumption. This results in overall higher specific energy section, causing deteriorated performance. So this was eliminated. Solution, we came to solution, we have changed DC over voltage and under voltage protection limits which were changed, and PLC program was modified to make change capabilities. Following field instruments of preheater fan were checked and calibrated precisely, like position transmitter of damper actuator and limit switch of damper, vibration sensors of preheater fan, and bearing and winding temperatures of the sensor, and interlocks were checked so that if any unwanted things happens, they can trip the system safely. These are the figures. Advantages achieved. The preheater fan can be operated at lower RPM, less than 68%, without any changeover in the GRR in safe manner. Electrical power saving due to increased range of speed control through SPRS. Smooth speed control through SPRS as compared to GRR step control. has raised the motor and fan. Then process consistency by increased range in speed control through SPRS and damper operation was avoided in combination with the speed control of GRR to reduce the fan flow. Normal operating speed of reduced to 70% instead of 74% with this. Data analysis, before this modification 751, after that 749, 2155 kilowatt circuit power, it has reduced to 2005, and preheater fan RPM 737, it has reduced to 696, and time to switch GRR to SPRS 5 to less than 1 hour. So these are the saving calculation. At the tune of 75.7 lakhs per annum we are saving last 2 years. These are the online trends, which shows the consistency in the process as compared to GRR. Conclusion, smooth running of the plant achieved with electrical power saving as above. Process flow and optimization is achieved with the speed control by semiconductor device instead of damper and GRR control method at lower RPM. Improved range of speed control achieved while using SPRS fan control of preheater fan. Equipment and process trouble was addressed and resolved with technological innovative approach with exploring extended span of control. Thank you.
Thank you, Mr. Srivastava. It's good that you can use your old SPRS without replacement with the VFDs. And ultimately, you will have to go for a VFD. And you can use same motor with VFD by shorting the slip rings. Thank you.
Thanks.
Now, the advantages and developments of waste heat recovery system in cement plants by Mr. Shri and Machintala.
Good morning to all of you. Thanks for NCB management for giving this opportunity to participate in this prestigious event. So myself is Srinivas Muchintala from ThyssenKrupp Industries, Pune. I would like to present advantages and development of waste heat recovery system in cement plants. So this is our headquarters in Pune. It's happy to share you that we have completed 75 years of formation. So there are 4 major divisions of our company: sugar, energy, mining, and cement plant. Boiler and power plant comes under the energy division. The waste heat recovery system in cement plant, the technology what we offer is ThyssenKrupp technology with steam Rankine cycle. And the product range is up to 300 TPH. The salient features of this waste heat recovery boilers is it's a tailor-made design which will vary from plant to plant based on the process data. And it's a self-supported, robust single drum boiler. It's a natural circulation boiler with cross-flow arrangement. This is the technology we follow for the waste heat recovery. So there are 2 major sources in cement plant for putting up the waste heat recovery. One is cooler and another one is preheater. Cooler boiler is called AQC boiler. The salient features of this AQC boilers are, it's a vertical or horizontal boiler. It's a cross-flow type with a tube design of finned cross-section. Because of the abrasive dust in clinker, we provide the heating surface as a finned one, and it will give the compactness of the boiler. And the boiler outlet gas temperature will be reduced to around 80 to 90 degrees centigrade, because there is no further process requirement from the cooler unless there is a requirement of cement mill and coal mill. And second one is preheater boiler. The preheater boiler, the heat source for the preheater boiler is outlet of the top cyclone of preheater. The tapping will be taken from the downcomer duct and it will be connected back to the fan inlet. The type of boiler is here also either vertical or horizontal we offer. It's a cross-flow boiler with natural circulation. Because of the high dust-laden gases, we use the bare tubes in this type of boilers. And to handle this high dust in the flue gas, we prefer the hammering system, which is a well-proven design of system to dislodge the dust. And we will provide the better accessibility for all the damper accessibility and all maintenance wherever is required. And it's a typical schematic diagram of the power plant in waste heat recovery, in cement plant especially. The cooler boiler, the gas will be taken from the cooler body and it will be connected to the boiler inlet, and cooler boiler outlet will be connected back to the ESP inlet. And coming to the preheater side, the downcomer duct tapping will be taken from downcomer duct to boiler, and boiler back outlet connected to the preheater fan. If there is no preheater boiler, then gas will be cooled down to the requirement of raw mill operation in the GCT. That means we are wasting the energy there. To recover the heat, then the boiler is introduced. Okay, then the steam from the boilers will be connected to the steam turbine, and condenser is connected at the turbine exhaust, and condenser, then the condensate flow taken to the deaerator, and again it back to the boilers through a feed pump, then it forms a closed loop cycle. This is the complete schematic of the waste heat recovery system in the cement plant. The solutions what we offer is based on the customer requirement, whether it is a boiler package or it's a BTG package, boiler turbine generator, or it's a complete EPC basis. Yes. The advantages of setting up the installation of the waste heat recovery boiler is it's a free power which reduces the production cost, and it reduces the carbon emissions, and it reduces the global warming, and it reduces the power consumption of the fans. Even though there is a slight increase in the pressure drop of boilers, but due to less dust load and the low temperature at the fan inlet, then it will reduce the power consumption of the fans. The developments in WHR system come across over the 10 years of our journey is the dual tapping from the cooler, and the introduction of hot air generator for the cooler side, integration of WHR steam into the CPP, and installation of pH boiler after pH fan. Generally, the preheater boiler will be placed before the preheater fan, that means in the downcomer duct. But the new development is installation of pH fan after pH fan. The CPH coil to reduce the water hammering in AQC boiler, and reduction of footprint by changing the pH boiler cross section from horizontal to vertical, and it's a hot air recirculation in quench cooler, and integral deduster in case of AQC boiler. So these are the developments happening in the waste heat recovery system. If you see the single mid tap, the tapping will be taken from the cooler body after the null point, then it goes to the AQC boiler, then AQC boiler outlet will be connected back to the ESP inlet. Then the system is same as explained earlier, the steam goes to the turbine and condenser, then it forms as a complete closed loop cycle. This is a single mid tap, that means only one tapping will be taken from the cooler body. And it's a dual mid tap. There are two tappings will be taken from the cooler body to maximize the heat recovery, and exhaust gas will be mixed with the boiler outlet gas to form a mixed temperature of around 110 to 120 degrees centigrade for which is required for the ESP operation. And it's a N tap, that means complete mid tap plus N tap gas. Completely cooler gas is utilizing in AQC boiler, and it's a hot gas generator. So hot gas generator is introduced to increase the temperature of cooler, which is having a low temperature. It will be gas temperature will be increased to 400 to 450 degrees centigrade, which is equivalent to mid tap temperature, so that it will boost the power. So the preheater boiler after preheater fan, the limitation here is booster fan is required for the operation of preheater fan, because the boiler will be placed after the pH fan. So there is one small limitation is that power consumption will increase slightly, but if there is no space provision is available in the preheater boiler, preheater downcomer side, then there is no option. We have to place the boiler at the outlet of the preheater fan. And this is the WHR integration into CPP. This is it's a very lucrative method. The CPP, the concept is WHR steam will be utilized in the CPP auxiliaries like HP heater 1, deaerator with the using of PRDS. Here, CPP heat rate will reduce by 9 to 10%, and CPP coal consumption also reduces by.
Please try to sum up.
Yeah. Yeah, CPP, this is a very good lucrative method. Yeah. Yeah. These are our installations. These are our word of appreciation. These are some photographs. Yeah. Thank you for your attention. Yeah.
Thank you, Mr. Srinivas, for your presentation on the waste heat recovery systems, wherein you have also discussed some innovative ways apart from the conventional way in which WHR systems are being installed. Thank you. Now the next paper is on energy efficient technologies and operations in MCW, presented by Mr. Rao and Krishna Kumar of My Home Industries.
Very good morning to all. Respected chairman and co-chairman and NCCBM team. First of all, myself Pankaj Kumar. I am presenting this paper on behalf of Mr. N.S. Rao, Energy Efficient Technologies and Operation in the MCW. This is the graphic view of the MCW plant where the 3 units are there. First unit is 2000 TPD, second unit is 3200 and third one is 3600. Total capacity of the plant is the 3.5 million ton per annum of the clinker capacity and the 3.9 million ton per annum of the cement capacity. To cater all the electricity, we have the 75 megawatt power plant is there and the 12.5 megawatt waste heat recovery system is there. My Home Industries Private Limited is the part of the leading business conglomerate of the My Home Group, and we are the other core business of the group are the construction, real estate, power, transport, power consultancy, and educations. MHIPL is currently has 2 integrated plants. One is at Suryapet district in Telangana, and second one is Kurnool district in Andhra Pradesh. The total capacity of the group is the 10.2 million ton per annum capacity. And we have the 2 integrated plant and the 2 grinding unit is there. My Home Group, My Home Cement MCW is the ISO certified company, and my unit has received the CIA Green Gold Rating Awards. We are producing all the range in the OPC 4353 HP PPC SD Plus with the brand name of the Maha Cement. And we have the strong dealer network of the more than 5,000 dealers across the spread across South India, Eastern India, and the Maharashtra regions. As I said, total capacity of the plant. We have the dry process of the cement manufacturing. 3 units are set up the state-of-the-art technology. First one is the Walchand Nagar. Second unit is supplied by the FLS, and third one is the KSD. Now, main topic, thermal efficiency improved in the preheater system. Why in the preheater? In the present scenario, to operate the cement units and are looking to optimize the fuel consumption due to challenges facing availability of the cost of the fuels. MCW focus on existing units to optimize the energy consumptions by identifying the heat losses which are contributing to the high fuel consumptions. The preheater system is one of the major areas for potential reduction in the thermal energy consumption in the plant. The main of the preheater system is to recover maximum heat from the kiln exhaust gas and to reduce overall thermal energy consumptions. As I said, my unit 1 is the 2,000 ton per day capacity of the small plant is there. So preheater exit temperatures are running 375 degree. When I compared with the similar stage of the 5-stage preheater to the other plant, is the outlet temperature is running 322 degree. So there is increase of the 55 degree, which is directly loss. Heat loss due to the preheater exit temperature resulting in the high specific heat consumption also. As you said, see the comparison between the my plant and the standard 5-stage preheater, with the preheater exit temperature are running at the 375, whereas in the standard preheater systems are running at 320 degree. So what are the probable reasons for high heat consumptions? There are poor heat transfer in the cyclone riser ducts, improper flow and metal distributions, high velocities in the riser ducts, low top cyclone efficiencies. So CFD studies is proposed to pinpoint what, find out where is the heat losses in the ducts and the cyclones. So what is the CFD? CFD is the basically computational fluid dynamics, one of the branches of the fluid mechanics that uses numeric methods and algorithms to solve, analyze problems that involve fluid flows. CFD predicts fluid flows with the complication of the simultaneous flow of the heat, mass transfer, phase changes, and chemical actions using set of certain CFD software and the calculations. So we have conducted the CFD studies at the Unit 1 preheater by the Messrs. Maxwell. The benefits from the CFD studies are as a reduction in the preheater exit temperatures, uniform gas flow and the proper metal distributions, reduction in the pressure drop in the preheaters. As you see in the present condition and the modified condition, there is a turbulence in the flow, which are resulting in the high pressure drop as well as losses in the specific heat consumption. Whereas in the second picture, there is the uniform flow is there in the riser ducts. And whenever the turbulence is there, along with the pressure drop, the heat losses is also there. So based on the recommendation of the CFD analysis, in the existing cases, flow distribution is highly turbulent and circulating in the nature, whereas the flow distribution is improved in the modified cases. In the existing case, flow separation and the recirculation zones are observed across riser ducts 3 to 2 and 4 and 3, whereas the flow separation regions are avoided in the modified case at the preheater systems. In the existing case, turbulence and the circulating nature of the flow resulting in higher pressure drop, whereas in the modified case, flow is made nearly uniform and circulating zones are avoided. So based on the CFD reports, we have added additional 1.5 meters of the feed box by the distance piece, as you see it in the second pictures. What are the results? Temperature difference at the cyclone 3 to 2 riser ducts, we are saving of the 15 degrees centigrade. Preheater exit temperatures, we gain in the 10 degrees centigrade. Whereas the major gain in the preheater cyclone top cyclone exit pressure is the 30 mmWg. Preheater exit losses 5 kcal per kg clinker, and preheater's fan specific power consumption is 0.36. So results achieved after the implementation, the reduction in the pressure drop by the 30 mmWg reduced the fan specific power of the 0.36 kilowatt hour per ton of clinker, resulting net saving of an account of fan power is 12 lakhs per year. And by the reduction of the heat consumption by 5 kilocalorie per kg of clinker, resulting saving in the 45 lakhs per year. So total savings by this CFD analysis and CFD proposals, we could achieve the 57 lakhs per year on the energy conservations. Thank you.
Thank you, sir, for your beautiful presentation showing the savings achieved by implementing CFD analysis in the preheater circuit. Now the next paper is an innovative vortex reducer to reduce pressure drop by 20% in preheated top cyclones by Mohammad Fazil, Joshi and Sanjeev of Ultratech Cement along with Mr. Raju Goyal.
Honorable Chairman, Co-Chairman, NCB representative, and dear delegates, a very good morning. My presentation topic is an innovative vortex reducer to reduce pressure drop by 20% in preheater top cyclone. Cyclones are very important device in cement industry. These are like kidney in human body. My name is Mohammad Fazil. I am from Ultratech Cement Limited, Mumbai. Ultratech Cement Limited is the cement flagship company of Birla Group, and it's the second largest cement manufacturer worldwide, excluding China. Also, largest white cement manufacturer. It has 22 integrated unit, 1 clinkerization unit, 1 white cement, and 27 grinding unit, 8 bulk terminals, 170 ready mix. Ultratech Cement is a founding member of Global Cement and Concrete Association. It has its own cement R&D center to focus on new product, process, and sustainable development. This is roadmap of my presentation. I will go through observation, objective, CFD modeling process, optimization approach, result analysis, implementation at site. Conclusion. Observation. During the pressure drop reduction action plan, the plant team observed high pressure drop in top stage calcinizing cyclone. The pressure drop reduction has been identified as potential area for energy reduction. Objective: improve energy efficiency by reducing pressure drop in the cyclone system. CFD modeling and optimization to reduce pressure drop without compromising separation efficiency. This is our main objective. Minimum modification, maximum benefit without compromising with separation efficiency. This is the process data. We have taken measurement before this modification, and for CFD parameter we have taken from this data, especially velocity 14 meter per second, viscosity ECT. This is the workflow for CFD. This is the systematic workflow for CFD. First thing, we have to prepare geometry model, grid generation, and CFD setup. After that, calculation and post analysis. Now this is the if and else kind loop. If objective fulfill, we can recommend for implementation, and post implementation we can analyze benefit. If not fulfill, then we have to repeat same step again and again to achieve our objective. Geometry and meshing. Geometry, there are many 3D modeler, especially parametric concept and blended approach. We use parametric because we are dealing with dimensional change. So especially ANSYS range modeler, there are many SolidWorks and ProE, all those things. Mesh selection, there are many mesh type, tetrahedrons, hexahedrons, but we have used 3D tetrahedron mesh for better for complex geometry, easy to generate and maintain consistency. Prism layer used on near wall. We have simulated 4 cyclones, including inlet and outlet duct. We have taken 250 mm base cell size to generate mesh. This is the CFD modeling approach. Cyclones are multi-phase phenomena. It consists both gas and solid particles. We have modeled Eulerian-Lagrangian model, and discrete phase at very less volume fraction. So we have used one-way coupling to predict efficiency of the cyclone. Turbulence model, we have used Reynolds strength turbulence model because cyclone separation is a swell dominating flow phenomena, so Cap-Salon type model is not capture realistic flow. Optimization approach, it was very challenging to identify unique modifications since both strings have different type of cyclone outlet. It was thought-provoking activity to reduce pressure drop across the cyclone with maintaining existing efficiency. There are 2 approaches. Shape optimization approach, basically we optimize inlet, dip tube, cyclone height, etc. Other approach is optimization with additional structure. I have referred this D. Noller et al. 2004. So we have designed this particular innovative vortex reducer. You can see here to optimize pressure drop. These are results. Pressure drop in high pressure zone reduced by increase in low pressure zone. Thus, pressure drop reduced in modified case. Result analysis continue. Tangential velocity reduced in outer vortex, increase in inner vortex. Shift in vortex transition, this is the very main observation, can be observed in modified case. Result analysis continue. Result in tangential velocity and shifts in tangential velocity peak breakdown of soils help us to improve overall cyclone performance. I have plotted this 2 meter below dip tube velocity and tangential velocity. This is very important slide. Pressure drop across cyclone system predict through CFD 97.3 mmWg, while we have measured average 97 mmWg at site. Vortex reducers suggested for 25% reduction in pressure drop. I have given site before, CFD before, CFD after, and site after. Pressure drop comparison include post-implementation benefit. You can also see there is no adverse effect on cyclone separation efficiency. Implementation at site, the vortex reducer is positioned at the site with additional support. The additional supports are provided to prevent possibility of structure failure. You can see vortex reducer in fabrication stage and vortex reducer after implementation. Conclusion, the present study suggested computational fluid dynamics simulation with higher order numerical scheme provide very close agreement with industrial data. We have designed this vortex reducer for industrial cyclone was designed and proposed for implementation to reduce pressure drop by 25%. Ultratech Cement Limited implemented and monitored benefit. After implementation, we achieved 20 mm WG reduction in pressure drop at 20 TPH higher production. I like to thank my process head and project department head and plant team. Thank you so much. Allow us to do this experiment in the plant. Thank you, audience.
Thank you, Mr. Fazil, for your interesting paper on saving about 20% reduction in pH circuit drop, pressure drops, and thereby increasing the production. A good paper. Now, the next paper is on upcoming technologies for renewable sources of energy. Sunil Shah, Mr. Pawan Mathur, and Raju Goyal of Ultratech Cement. Okay. So these may come afterwards. Now, the next presentation is on the 8th one. Okay. The energy reduction through innovative approach and adopting energy efficient technologies by Suman Nath, Chandan Singh and C. Anil Kumar of Calcom Cement India Limited.
Good morning to Chairman, Honorable Chairman, Co-Chairman and NCCB representative, and to all the audience present in this auditorium. First and foremost, I would like to thank the NCCBM for giving us the opportunity to present our paper, Energy Consumption Reduction Through Innovative Approach and Adopting Energy Efficient Technologies. Myself, Shri Suman Nath, from Calcom Cement India Limited. We are from Umrangshu, Assam. Talking about the paper, nowadays reduction of energy consumption is a matter of priority, especially for cement sector. Because as we all know, cement production is a very energy intensive process. The total cost make up about 30 to 40% of total production cost. Increasing economic pressure introduced by a competitive market also asked for a reduction of energy consumption. And last but not the least, reduction of available energy resources is important, very important. So, just I want to give a brief introduction of our Calcom Cement India Limited, Umrangshu. Our group, Dalmia Bharat Group, was founded in 1935 by Sri Jayadeva Dalmia ji. Our plant, Calcom Cement India Limited, was established in 2004 by other group. In 2012, Dalmia took over the plant. At that stage, the plant was in erection stage. In 2015, the plant was commissioned. Talking about the major plant specification, ours is 3,400 TPD utilization unit with single string 5-stage preheater. For raw mill and cold mill grinding, we have VRM of 285 and 25 TPS capacity respectively. For crushing, we have an impact crusher of 700 TPS capacity. So the major initiative that we have taken for energy reduction is capacity upgradation, initiative for SPC reduction, and initiative for SSC reduction. Talking about the capacity upgradation, as I have already mentioned, our plant is designed for 3,400 TPD. It comes out 6.5 volumetric loading. But we took an initiative to increase our capacity to 8% volumetric loading. And for that, we have taken various initiatives like upgradation of clean field bucket elevator, clean field main drive upgradation, process fan upgradation, and debottlenecking of projects. So this initiative, I am very happy to inform that Right now, we are operating our plant at 4,000 TPD from 3,400 design TPD and achieving a volumetric loading of 7.5 at present. Talking about the initiative for SPC reduction, first, one of the major initiatives that we have taken was upgradation of our process fans. We have done a comprehensive study of our process fans and found that a lot of our fans were operating at a low efficiency. So we decided to upgrade them with high efficiency, high capacity fans. As a result, we have changed our preheater fan, Romeo fan, RBH fan, Corp fan, 3 numbers. As a result of these changes, we have made energy savings of around 3 units from this fan only. Another major initiative that we have taken was CFD study and its implementation. We have carried out CFD study in our pilot section and as well as Romeo section to identify the problematic areas, to find out the flow separation and recirculation in ducts arrangements, optimization of turbulence by designing the guide plate, modification in ducts wherever required to reduce the pressure drop and improve heat transfer. By this modification, we have been able to achieve a saving of 0.5 unit in our preheater section and 0.22 unit in our Romeo section. These are some photographs of our CFD study and the implementation. If you can see the left-hand side, the before picture is there, and the right-hand side, the after modification, the picture is there. Before, there was a lot of recirculation is going on there in the duct, and after the recirculation has reduced, and pressure drop has been reduced by around 40 mmWc. These are the CFD diagram of Romeo section, Romeo cyclone. Solar plate or arrangement there. And in the bottom portion, we have seen the RABH invert pre-convecting hopper, where the dimensions are little changed. As a result of this, we have got very good efficiency in, very good savings in power. The next modification that we have carried out was the modification of Romeo and Corp ducting. We had very high pressure drop in Romeo and Corp duct as a result of high velocity in the duct. So we increased the dia of Romeo duct and Corp duct. As a result of this, the pressure drop in Romeo reduced by 25 mmWc and in Corp by 110 mmWc. And we got a savings of 0.36 kW in Romeo section and 0.2 kW per metric ton clinker in Corp section. Talking about the other specific SPC reduction initiatives, like replacement of reversible belt conveyors with wide chutes, installation of BFD in all delasting backfeeder fans, conveying road blower, RBH, RFN, etc. And then FRP beds for shell cooling fan, and interworking with Queen shell scanner, interworking of cooling tower fan with water temperature, optimization of conveying air, installation of LED lighting, high efficiency water pump, resting of false air, and removal of damper of fan from inlet wherever possible. Now, coming to the SSC reduction initiatives, we have created a lot of initiatives in SSC reduction also. Just as I mentioned in the CFD of our preheater section, that also gave us a heat savings in 3.6 kW due to better heat transfer in a preheater top cyclone. Then change in ROMIX. With certain changes in ROMIX, we have been able to achieve a reduction of 14.2 kcal per kg clinker because of reduction in heat of reaction. Then we have upgraded our burner from traditional medicinal burner to KSD pyrazole burner, and we have also installed a Queen outward seal, which has given us a savings of 2.8 kcal per kg clinker. Then false air reduction with continuous monitoring and timely action, false air in the preheater circuit, we have been able to reduce from 7.2% to 5.3% at present. The PC height, one of the major initiatives that we have taken is increasing the PC height. We have increased our PC height from 54 meter to 101 meter to increase the residence time and minimize CO formation, which has given us a savings of 4 kcal per kg clinker. And upgradation of clinker cooler. Earlier, we used to have a conventional gate cooler, which we have replaced now with a ICANN pendulum cooler, and which has given us a savings of around 20 kcal per kg clinker. The last two initiatives that I have mentioned, we have completed in this financial year only. Talking to the way forward, we have waste heat recovery system of 6.2 megawatt, and I am very happy to inform that as of today, we have already started generating power from this waste heat WHRS, and installation of coal bending and feeding system, and feasibility study for enhanced usage of alternative fuel in pyroprocess section. Here we are showing the PC height increase. As you can see in the left-hand side, it was the earlier, before modification, PC height, and after, we have increased the height from 54 meter to 101 meters. So increased the height by 47 meter. We can say we have increased the height by around 90%. and the residence time, which was earlier 2.8 seconds, we have been able to achieve it 5.2 seconds. It is to 5.2 seconds. It was a major initiative. Conclusion. From the last 3 years data, we can see our power consumption has come down from 56.52 to 50.92. And I'm very happy to inform you that as of today, our power consumption is less than 49 in this financial year. And similarly for heat consumption, from financial year 20, 739, in the financial year 22, we have come down to 713. And as of today, we are less than 690 in our power consumption. So the conclusion is the Indian industry has been drastic improvement in overall specific energy consumption over the last 7-8 years, but there is still significant opportunities present by innovative approaches and using energy efficient technologies. So we can use it more, and we can further reduction of consumption is available there. Thank you.
Thank you, sir. Thank you for giving insight into the steps taken by you in your plant for reducing the specific energy consumption. A very good approach so that you have reduced energy substantially. Now, I invite Mr. Sunil Shah, Pawan Mathur and Raju Goyal for presentation on upcoming technologies for renewable sources of energy.
Before that, with the permission of chair, I have an important announcement. May I, sir?
Yeah, sure.
So, this is an announcement for JK Lakshmi Cement. Mr. Mukesh Kumar or Mr. Sunil Kumar Saxena or any representative. We are awaiting your presentation. So, please make it available ASAP so that we can include it in this session. Only 2 presentations are left. So if it is received well in time, so it can be considered in the session. Thank you, sir.
Yeah.
Good morning, and thank you, NCB, for giving this opportunity to present here. Topic for me is renewable energy, and mainly floating solar and wind solar. Floating solar is also known as third pillar of the renewable energy, but majorly it has not been consumed till date in cement industry to a larger extent. So that is what I'm trying to present here. Let us go through the problem statement again. Rising fuel cost, we all know the coal cost after the geopolitical situation in Ukraine, Russia, and then decarbonization requirement. We have been discussing this for last 4 days. So these 2 areas are very much hindering the progress of country and cement plant as such for benefit and sustainability. So we are aware that almost 61% of the cost, 61% of the cost is power and fuel cost for cement industry. And if we can reduce it somehow, then we can reduce the carbon footprint. So that is the issue we are facing at this moment. Now, what companies are doing, like Ultratech or Dalmia, so what we are trying to do is, we are trying to change our power mix. And power mix, we are changing it through various renewable energy, because we need to reduce the fossil fuel. So we are trying to change it with the renewable sources of energy, like WHRS, solar, all those technologies which can reduce the consumption of coal. And like day before yesterday, somebody was telling that they have also installed floating solar. So Ultratech is also trying to move into those direction, and we also have now floating solars at 1 or 2 our locations, and we are moving forward into that direction. Currently, our percentage of power mix to the renewable is around 17 to 20%. Precise figure is around 20%. So we are trying to increase it, and we have our targets to do this by 250, net zero by 250 means uses of all renewable energy to run our plants. Just to have an understanding on the floating solar, what it is. First part is solar modules, like ground mounted.
these are mounted on the floats. So photovoltaic cells, similar as ground mounted. Second is floaters. This is very important part in this entire floating solar system, because you have to take the load of the cells, not for 1, 2 or months, for years together. So it has to be very good in, say, tensile strength, temperature, or many other parameters. And it has different configurations. So floaters are the most important part in this entire floating solar system. And around 50% of the cost is floating for the floaters in this system. So the cost of floating solar system is slightly higher for as compared to the ground mounted systems. Third part is anchoring and mooring device. So because you have to keep your floats, your system intact, there will be lifting and dragging forces whenever there is change in wind velocity. So you have to take care of that, and that's how anchoring and mooring portion, the parts, they take care on this. So you have to put concrete blocks near the shore, and then you have nylon ropes, and you have to design all those things in such a way that whatever the wind velocity or whatever the changes in the weather conditions takes place, that is able to take care of that. Next part is cables. Cables also forms very important part, because we all know that electricity and water are enemies. So the insulation of the cables has to be very good if we are putting underwater cables, or it can be laid on the floats also. So specifications of the cable also needs to be perfect. Next part is inverter. Inverter, you can keep it on the shore, or you can keep it on the floats also. So it's a choice where do you want to keep it, and you need to see from the maintenance perspective also what is right place to keep it. So these are main parts. Then there is transformer, and then transmission system. So that is the main part of a floating solar system. Let us try to understand what are the pros and cons of a system. Floating solar does not require land. So any state, any country, or even any plants where the land is scarcity, then floating solar is a good option. Like for cement industries also, we have mine pit, so we can have these solar systems there. Second thing is, you don't have any civil requirements. So we all know that leveling, cutting of the grass or trees, that's a cost into installation of solar system. But in this case, we can save this also. Commissioning is very fast, because you don't need to do the land preparation, which takes 2-3 months or 4 months, then fabrication of structures. So that is also avoided into these systems. You also have water conservation, because when the solar system is installed, then water evaporation gets reduced, and it can be up to 40%. Whatever installation you do beneath that, it can be up to 40% water evaporation can be saved. Then, due to the cooling effect, the degradation of the photovoltaic cells, suppose the life is 25 years, it can also be extended. So there are research results that the life of photovoltaic cells also increases with the cooling effect, because it is temperature dependent. Then efficiency of the solar system is higher than the ground mounted system because of the temperature effect. So we will go to the next slide and understand what are the exact differences. Dust exposure is lesser, so cleaning requirements are also less for this. Then algae formation is controlled, because on the surface side this is there, so algae formation is also less, and this is improving our environment. What are the points to be taken care for floating solar? One is electrical safety. So at each step, selection of the cables, then protection settings at the inverter, protection settings at the transformer, and many more things you need to take care so that on a longer run, you don't fall flat on that. Then there is risk in abnormal windy and heavy conditions. So those has to be assessed very firmly before putting a plant, that what is the history of this reservoir, pond or pit, that what can be the maximum wind velocity, or what can be the water level changes, that has to be taken care very well. And then there is a study called bathymetry. Bathymetry is necessary. Bathymetry tells about the water body changes over the period of time, level changes and many other things. That is must to do. There is slightly more difficulty in doing the maintenance of floating system, because you have to go up to that level, you have to work on the floats. So there is a slightly higher maintenance requirements and difficulty. So that needs to be kept in mind. And cost, I told that cost is higher than ground mounted. How much costlier? That we will see in the next slide. These are the key parameters for a system. So land requirement, if we see as the space side, so 25% less space is required. Land use efficiency means how much generation we can do in the same space, then it is 50 to 20% higher efficient. Performance ratio means theoretical versus actual generation, so 2.5% higher. These are all tentative figures on average figures. Capacity utilization, this is the main parameter, means how much radiations we receive and how much output we give. This is the main parameter for any solar system evolution. So around 8 to 10% higher generation we can do through floating solar. So what I mean to say is, whenever we are evaluating floating solar versus ground mounted, we have to see in the life cycle, not only on the capex cycle, capex amount. And the capex amount, if we see up to 10 megawatt, 6.5 crore per megawatt is the cost for floating, and ground mounted we have the cost around 5 crore per megawatt. By around 2025, we will be having around 13 gigawatt peak of floating solar installation in worldwide. So, and Asia is playing a very good role, India, China, Taiwan, and Japan. So what I mean to say is, the cost of these systems are going to come down. So there is an opportunity we can put it in our cement plants as well. The second part is wind solar hybrid system. So when we use wind and solar.
Please hurry up.
See the generation curve. In solar, the generation curve is peaked at a particular time, but in hybrid system, we have generation curve throughout the day. So that's a benefit. Round the clock availability is there for the generation. And we can use our electrical resources very well, because the generation is continuous. So whatever electrical capacity you have as per the contract demand, so you can utilize that capacity very well. From the banking point of view also, these systems are good, because when you are putting it on-site, hybrid systems, then you are less dependent on the banking system. So that is also good. So since banking system dependence is less, so transmission cost will also be lesser. So that's the benefit, the major benefit of the hybrid systems. But you need to have the wind velocity for that. That's the main point in the hybrid systems. And then only it will be viable to you, and you will get the consistent this. In the future also, we will be having the storage technologies. So hybrid plus storage will make a very good combination. at that point of time, and we will be less dependent on the grid or any other sources of the power. Thank you very much. Thanks.
Thank you, Mr. Suman, for your beautiful presentation. Now the next presentation is by Mr. N. Sundaran of ICANN Engineering, Recuperate, Cool and Sustain.
Good morning, ladies and gentlemen, and thank you for this opportunity. And let me go into the presentation straight away. Myself, Soundaraj, and on behalf of ICANN, I'm going to present this fascinating news about ICANN. Let me start with the basic and important functions of a clinker cooler. Recuperate the heat back to the kiln and cool the clinker with the lowest power possible. And if you look into this last two decades, there will be the multiple capexes for the same equipment. For your operating team is asking after 5 or 7 years of cooler installation that I need one more cooler upgradation because of the deteriorated energy levels and increased power consumption and increased fuel cost and so on, and the reliabilities, etc. We ICANN believe that an equipment, if you install, it should sustain for 20 years, and the operating parameters and the guaranteed parameters should sustain for the longer period of time. Then only it plays an important role in the energy conservation and also for the benefit of our future generation. So another third important function, which is the criteria to selection of the cooler, is sustain the performance for the longer period of time. To sustain the performance for a longer period of time, the equipment should be built with the strong fundamentals like what ICANN have is KITS 4.0, Konda effect, LPS, linear pendulum suspension, and a simple and efficient drive, which is located outside. And now, we have a strong fundamentals to have a better recuperation, sustain the energy for a longer period. Now, the clinker is getting finer and finer, isn't it? Yes, when we have a challenging targets like net zero carbon, and green fuel is increasing and low calorific value fuels also increasing, the kiln operation is getting disturbed. Last 4 days we are looking at the presentation from the various vendors that they have operation challenges of refractory, for example, and any equipment wear and tear are very high. Then under these challenges, how do you have a sustained and reliable operation? So ICANN is upgrading further on fine-tuning the fundamentals to have even better to counteract these challenges. One of such is KITS 4.0. It means the KITS, which was introduced in 1983, is the same with the strong fundamentals, but we are fine-tuning for the latest challenges. The 4 important features which the KITS 4.0 has is a hybrid aeration, a dynamic transport segments, a variable slope, and based on a proven concept called Konda wings. What does this hybrid aeration do? When you have a coarse clinker and also the fines clinker together, for example, it is typical for the Indian kiln. For Indian kilns, we produce clinker with a 32%, up to 32% liquid content, and also with a very fine pet coke with a very fine clinker. Under these circumstances, when the material, coarser material, agglomerator material is coming into the center of the cooler, which may not move as quickly as fines. So you need to have a strong center aeration. When you aerate strongly in the center, instead of it forming a hill, it creates a valley, and the fines coming to the center, and thus your red river is pushed to the center of the cooler. Further, with the corner fans, you can retain the fines little longer by reducing and controlling the airflow, and thus your residence time of the fines and cores will be at the same, and the discharge from the kits to the next following grade will be uniform. And thus your like upset conditions can be kept very, very narrow, and it is which is very essential to keep the highest recuperation as much as possible. The next is the snowman. When you have a highest liquid content with the AFR, chlorine, sulfur, and etc., the snowman tendency is also increasing. How do you handle this snowman? The industry is telling that increase the number of air blasters, or increase directly connect the air blaster nozzle to the cooler plates. But ICANN feeling is that if you increase the airflow, compressed air, too much into the static inlet or into the cool operating system, it will disturb your clinker bed, and also continuous high pressure cold air is not good for your secondary air and tertiary air temperature and kiln operation. So what ICANN does is, we are combining the 5 kits nozzles together and connecting to a drive underneath, small drive underneath. Through this, you can move the kits, selected parts of the kits, to move the snowman from the base out of the kits easily. So with this, we are telling that now we introduced the static inlet in 1983. That static inlet is essential. Everybody has followed the same design in their own coolers. Now we are telling it's a patented design that kits can be moved as and when required with the specialized geared motors. And this inlet motion device is a part of the kits 4.0, which can be optionally used. It doesn't mean that it's a mandatory requirement that you need to procure along with this kits 4.0. It can be installed at any point of time when your fuel and operating conditions are getting challenged. So this is a kits 4.4 with IMD. The next one I was telling was the inclined slope, variable slope. That means kits essentially designed with a 15-degree inclination to move the clinker uniformly. But when you have fines, it is difficult to retain the clinker. So when you have too much of fines, like 50% more than less than 3 mm, then you can reduce the slope back to 10%. So when your granulometry is changing, again you can change in the next shutdown. So this is with the variable slope, and Conda Wings kits 4.0 is even better under upset operating conditions to have a better and sustained results. The next, kits is doing a better job in the recuperation, and how do you make sure that your cooler efficiency is sustained? The main problem with this older coolers is that the roller supported mobile structure, which was creating a lot of gaps in the grates after a few months of operation. So with IK and pendulum support, the mobile structure, the zero position will remain same for the longer period of time, and this is maintaining the uniform profile, the gap management, which is the secret of clinker cooling and recuperation. So the grate gap management is uniform, and your grate resistance is uniform, and hence the air bypassing through the passage of, that means short circuiting of the air through the gaps are completely eliminated, and hence your recuperation is sustained for a longer period of time. And the kits is preparing the stratified layer. If you look at the cross section of the cooler, IK and bed will be looking like this: fines at the top and coarse at the bottom. It means the coarse will have a lower clinker, lower clinker heat, whereas the fines will have a lot of surface area and latent heat and hence high temperature. This advantage of this is that when the air enters from the bottom 30 degrees, it's getting uniformly heated up in a very short time. That means we have only limited time in the recuperation zone, maybe 10 to 12 minutes, like I have the time for this presentation. So within the 10 minutes, you have to take recuperation as much as possible. So this clinker layer should go unmixed till the end of the cooler. If you start mixing this cooler, it may be recuperating. Mixing is good. It may be good if you have infinite time to recuperate, but you do not have. So you need a stratified sharp clinker bed to recuperate it. So once it's created in the static inlet with the help of Conda effect, it need to be transported till the end of the cooler. Earlier we had PLC with the hydraulic drive. So with a slow forward and a quick retraction motion, we are able to maintain this layer till the end of the cooler, and hence your cooling is also better and recuperation is done within the null point. But now, with the challenging hydraulic conditions also, we are coming up with very simple DLD drive, dynamic linear drive. It means it has only this local control board and a geared motor, which is driven by a VFD, which is located just 100 meters inside the cooler building. That's it. Your drive is done. This dynamic linear drive, and with this, your mechanical team and electrical team is very happy. Their job is getting easier for maintenance. This overall view of IK and cooler, and it is looking simple, but it is powerful. The green section, which is located completely outside the drive area, and the red section is inside cooling chamber. It means it has no, it has only pendulum, which is a metallic part, and has no lubricated parts, no rubber oil hoses, no hydraulic cylinders, and no instrumentations or oil pipes inside cooling chamber. This is helping you to recirculate the hot air to all the chambers without any fire hazards. And this hot air recirculation concept is helping you to increase your green energy production through WHRS generation without any fire hazards and without any deterioration or any effect in the recuperation efficiency. And the important case study I would like to share here is the Dalmiapuram, which is a cement plant, which is completely, this cooler was installed in the pandemic time, and the pre-assembly has been done well in advance. And with the multi-pack arrangements, we are able to erect this cooler access to access 18 days. And how about the performance? The clinker temperature was, you can touch the clinker in the hand when the kiln is at full capacity. which is 40 plus ambient. To achieve this 40 plus ambient, IKN cooler was required only with 3.85 units of power, which for the fans and drive and roll crusher altogether. And 116 kilocalorie is the cooler loss with the normalized conditions, which is equivalent to 86 kilocalorie standard cooler loss of 1.15 kg per kg clinker recuperating air. So IKN has set various benchmarks, such as lowest cooler losses, lowest energy consumption, and faster erection, and so on. Another important benchmark IKN set is that sustained results for more than 20 years. In this slide, you can see that Lafarge RS Mehta cooler, which was installed in 2003, is sustaining the efficiency. That means standard cooler loss, which is 87, which is closely equal to the latest cooler which we commissioned in Dalmiapuram, and performance test was achieved. And the power is only 3.1 units. It means the power consumption is also very low for this condition. With this cooler is outbeating the any latest generation cooler available, and this is what the remarkable sustainable efficiency which IKN is advocating so far. And same results we can see. 2014 we have installed Ultratech cement Rajashree 4 and Ravan 2. If you compare the results, this is also sustaining till March 20th audit. We are sustaining the results, and now we have 16 coolers from Ultratech, and from Dalmia we have 7 coolers so far. So with these results, IKN is building the trust among the customers and the services, energy efficiency, and also IKN tells that we can sustain the energy efficiency to the industry, and which is a choice for the customer at the moment. And innovation and sustainability define the leader, and thank you, our valuable customers, to keeping us in the leader and on sustainability as an important theme. Thank you very much. Cool down.
Thank you, Mr. Saundaraj, for your beautiful presentation. With this, we come to the end of the paper presentations. Total 8 number presentations were there. Now, I invite any questions for the presenters, if somebody has any question on the presentations which have been done.
First question from IKN, whatever the kits, myself Sanjeev Shrestha speaking, whatever a kits 4 is there, so whatever these results are being given, that is on a kits 4 design or something else?
Please give him mic.
So as I was saying, the fundamentals is same. Kits 4.0 or kits same. Fundamentals are for recuperation efficiency and this, results. The kits 4.0 is to counteract the challenges. Mainly we have learned this in last 10 years, which is we are started using AFR and tough.
So kits 4.4 is installed anywhere, that is my intention to understand. So when it is coming into the market?
It is already in. Dalmiapuram is with
okay,
kits 4.0.
So Dalmiapuram is the first installation of kits 4.0.
Correct.
Yeah, good morning. I have a small question to the WHRS Tyson Group. So, Indian cement industry is trying to claim that WHRS is equivalent to RE power. That is okay. Whether government will approve or not, that I do not know. Bureau of Energy Efficiency is trying hard to get it approved, it equivalent to the RE power. On the other hand, if we are adding additional coal and burning coal for upgrading the WHRS power, then the purpose of the WHRS power equivalent to RE will be totally defeated.
Yeah, I respect your question, sir. So here, coal is very minimum amount of coal is firing, and there is no problem with NOx and SOx. Because
sir, it is not the question of RE power means 100% renewable power.
Yeah.
How it can be 100% renewable power once we make it fuel-based power?
Yeah, it's a customer choice, sir, because it's you can boost the megawatt, you can increase the megawatt up to around 30 to 30%.
That I understand.
Yeah.
But then this WHRS as on a plain basis cannot be approved as a RE power.
Yeah,
that
right,
is my
yeah, it's a solution. So it's based on customer choice, sir.
Yeah, Mr. Kalra, may I intervene? I think you have raised a very pertinent point, and cement industry should look forward to first, have an efficient heat absorption in our cement plants, maximum recuperation in cooler, and minimum exit temperature from the preheater. Then only comes the real waste heat recovery power. If we
Exactly.
then because, the turbine efficiencies, power plant whole efficiency with the low pressure turbines, it is less than 25, maybe 20 or 22%. And if you are consuming that energy in the cement process itself, it is a total conservation of the heat there only, utilization
That
there
is
is there.
basically the waste heat is only the which is available for generation of the power. That is the waste heat.
Yeah. So
And once we are adding coal,
it's not a waste heat. Then you are
then it is not a waste
using
heat.
the
Cement industry
coal.
is trying since more than 15 years that it should be given as either RE power or green power, and MNRE has not approved so far.
See, government
I
is
was
also
one of the member of that team. In 2015, we have fought very hard with MNRE, and we could not get the success. Again, now on behalf of this Ministry of Power, BW is trying.
That's okay, but you see, even the CPPs which are used in cement plants are less efficient. That's why government is promoting super thermal power plants so that you buy power from the grid which is efficient. As a country as a whole, you will be consuming less coal if you use power from the super thermal critical power plants. Similarly, if your cement plant is giving, even a 20 units per ton of clinker generation from WHRS, maybe that is the, I think, ideal one. Maybe nowadays people are going up above 45, 49,
I agree.
which
Yes,
may be wastage of the energy as such in strictly speaking conservation terms.
BW is also promoting to switch over from your captive power to grid power. Now the different experience in different states is still persisting. That's the reason people are not switching over. Now by force, because of the high coal price, people have switched off their captive power and trying to switch over to the grid power. Yeah. BW is promoting since last 1.5 years this agenda also.
Okay. Any other questions?
Yes. Myself Arun Das from Amri Cement Limited. Question for WHRS itself. You explained for this double mid-tap instead of single mid-tap. Yes. How it is useful and what is the gain in this?
So gain will be approximately 1.5 to 2 megawatt will be the additional megawatt we can get it from this system, dual mid-tap.
But the flow will be the same, na? Either no. You take from single mid-tap or double mid-tap?
No, flow is not exactly same, sir. The flow is a little bit, the flow will be increases and temperature is also increased in the second mid-tap. Because of that system, we are able to generate the additional power of 1.5 to 2 megawatt.
For what capacity kiln? It depends on the kiln TPD, no?
Yeah,
1.5 megawatt
is for 8,000 TPD, I'm talking.
Okay, okay.
Yeah.
Thank you. Now I think we have a limitation of time. I'll request our respected coach. Okay. One last question, Mr. Verma, please.
My name is O.P. Verma from Prajim Johnson Limited. My question again to the WHRS. See, we are discussing in terms of energy efficiency in the pyro systems. Everywhere we are talking for the efficiency. Ultimately, it is resulting the low flue gas temperature from the cooler as well as from the preheater.
Yes.
So my stage question is that, do you have any technology or it is upcoming technology to get more power from the low temperature flue gas, like in terms of below 200 degree or maybe 100 degree below? So if any technology is available with you or something is there that if you can highlight it.
So presently we don't have any technology to recover the heat after the cooler boiler because the temperature is around 80 to 90 degrees centigrade. So that can be used for only for water heating only. We cannot generate with any steam from that amount of heat. We have to use for the heat only for water heating. So that we are not come across that requirement.
Okay.
Thank you. Maybe you can use that heat to, dry the AFRs being used, because converting into power is a very less efficient method. It should be used in the plant itself in the drying. Now I'll request co-chairman for his comments, please.
Yeah, thank you, Mr. Chairman. So, very interesting presentations, and what I in general see here, that nearly every part of the plant has potential for optimization. Therefore, CFD analysis as well as consequential 3D drawings are very helpful tools to reduce resistances in the system, to reduce delta pressure losses, to reduce excessive power and excessive heat use. Also, what I found very much interesting is the floating power plant, but unfortunately not everybody has the chance to install some power plants on the water side because they're somewhere in the center of the country. Anyhow, also what came out of some presentations is if we are using frequency inverters, especially for fans or middle main drives or big drives, we can put power back into the grid, what will give additional savings. Very often, let me say, frequency inverters will not be initially installed due to cost reasons. So I think also while installing new plants, certain capex have to be rethought and reconsidered in terms of really saving power and temperature losses. Generally, I'm very much thankful for the presentation, very interesting stuff. Thank you very much.
Thank you, sir. You have aptly summarized the gist of all the papers, so I need not say any more, only I'll say that we cement industry, we have to think ways of now recovering this low heat which we still find that is going out from cooler exhaust. We should use that heat, maybe as he said, to preheat water for CPP if those are running efficiently, or we can develop some hot air generators in which only AFR is fired, and to dry that AFR we can use such air. Some innovative methods which our cement industry is trying. I hope the low-hanging fruit, the energy conservation of coal and electricity is the front line, saviors for our aim to net zero carbon target which have been set by our government. Thank you for your apt listening and presence here. Thank you.
Thank you, sir. I would now request Shri Ankur Mittal to kindly present mementos to respected chairman and co-chairman as a token of respect.